Good morning, sir. This is Harshi Reddy from CSC, and I am going to explain about normal form 1NF, 2NF, 3NF. And this presentation will give you that what is 1NF, an example of 1NF, and characteristics of 1NF, and also 2NF, example of 2NF and characteristics, and also 3NF. Introduction to normalization. Normalization is a crucial process in database design. It aims to minimize redundancy and dependency in relational databases. What is 1NF? First normal form requires that all table entries or all entries to be atomic. It means to be unique. This means that each column value must contain individual values. You can see in the table 1 and table 2 also. Example of 1NF. Consider a table of students which subjects they are enrolled in. If a student has multiple subjects listed in a single column, it violates 1NF. And characteristics of 1NF. All attributes must contain atomic values for proper normalization. There should be no repeating groups or arrays within the table. What is 2NF? Second normal form builds upon 1NF by addressing partial dependencies. A table is in 2NF if it is already in 1NF and every non-key attribute is fully functionally dependent on the primary key. An example of 2NF. Consider a table where a student's ID and course ID together serve as a composite key. If the student's name depends only on the student ID and not the course ID, it violates 2NF. You can see in the tables. These will convert the 1NF to 2NF table. And characteristics of 2NF. All non-key attributes must rely on the entire primary key. Elimination of partial dependencies helps reduce data redundancy. And here you can see the 2NF dependency diagram. And third normal form requires that the table is in 2NF and has no transitive dependencies. This means no non-key attribute should depend on another non-key attribute. And you can see the two examples of functional dependencies like order ID, quantity, price, and total. In order ID it is a number, and price is a currency, and total also is in currency. You can see the second table, shipment. It is ID and provider, weight, and per B cost. An example of 3NF. If a table has a student ID, student name, and student advisor, and the advisor depends on the name, it violates 3NF. To convert to 3NF, you should separate the advisor information into another table. And I think all this is about 1NF, 2NF, and 3NF. And conclusion. Normalization is essential for efficient database design and management. 1NF, 2NF, and 3NF each serve to reduce redundancy and enhance data integrity. And you can see here 1NF, 2NF, and 3NF normalizations. In 2NF you can see that the all non-key attributes must rely on the entire primary key. And in 1NF you can see that all attributes must contain atomic values. If the attribute is said to be that 1NF means 2NF, it should compulsory follow the 1NF rules. If a attribute is said to be 3NF, it should always follow the 2NF and 3NF properties. Thank you, sir.